Other students. So this is second lecture of gravitation. In this video lecture, we will start with Kepler's law of planetary motion. Okay. So Kepler has given three laws of planetary motion. So first law is law of orbit. So every planet around the sun in an elliptical orbit, not in circular orbit, right? So this is a misconception that planets revolve around the sun in circular orbit. Actually, it's an elliptical orbit with the sun at one of the foci elliptical orbit. So ellipse has two focus. One is here at which sun is situated, and from center of this ellipse, if we take this line as central line, and this is also called major axis. This one is minor axis. What we call this? Minor axis, and this one axis is major axis. Major axis, minor axis. So sun is situated at one of its focus, and planet revolve around the sun in elliptical path. Is it okay? Not only Earth, even all planets revolve around the sun in different elliptical path. Second law, law of area. It's law of area. What it states, the sun joining the planet to the sun sweeps over equal area in equal interval of time. What does it mean? Equal in equal interval of time. Suppose you give chance to a planet to move for some time, right? So let's it move from A to B. And if you give that planet same time to move, but on another location, suppose here on perigee. Perigee is a point which is on elliptical path and which is nearest to the sun, and apogee is a point on elliptical path which is from the sun. So near apogee, if you give a planet chance to move for same time as given near apogee, then it will definitely cover a larger distance. And if you join sun with that two different positions, which is traveled in time t, and time in same time two different positions c and d, then area made by this arc ct and ab with sun will have same value, this area and this area will have same value, right? So we can conclude here that since these two areas are equal, so we can say that here from A to B, planet will move slower, and from C to D, it would have moved, right? So what second law state? Second law state, area of SAB will be equal to area of SCD. S is for sun, so SCD is equal to SAB. So second law tells us that a planet does not move with constant speed, right? It moves with a greater speed when it is, and it moves slower when it is far away from the sun, right? So not with constant speed around the sun. It speeds up while approaching the nearest point called perigee, and slow down while approaching the farthest point called apogee. Therefore, distance covered on the orbit, the given interval of time at perigee is greater than at apogee. Let's start learning third law, Kepler third law. So we will get numerical from this law only, third law. We will not get here numerical in this chapter from first and second law. So this is very important, third law. The square of the time period of revolution of planet around the sun is directly proportional to the cube of mean distance of sun. Why we are talking about mean distance? Because Earth is not always at fixed distance from the Sun. This distance is changing. Why it's changing? Because Earth is not revolving in circular path. It's revolving in an elliptical path. That's why distance is changing. So we take here mean distance or average distance of any planet and Earth. So square of time period is directly proportional to cube of mean distance between planet and the Sun. So if you divide t square to r cube, it will become a constant. So we can say that t square by r cube equal to constant. So Kepler law gave the law of planetary motion. He could not give a theory to explain the motion of planet, why planet revolving in elliptical path. Explained that the cause of motion of planets in the gravitational force which the sun exert on them. Newton's used Kepler's third law to develop the law of universal gravitational gravitation. Here, sun is situated at one focus of this elliptical path. This is focus, right? And this is perigee, and this is apogee, and Earth is here, and this is revolving in this elliptical path. And this line x plus y is known as major axis, and x plus y by 2 is distance from center to this planet, and this perpendicular line is minor axis. Okay, so there is a question in module which is a planet revolve in an elliptical orbit around the sun. The semi major axis A and minor axis B. Then the square of the time period is directly proportional to, as we know that time period, square of time period is directly proportional to mean separation cube of mean separation. So mean distance is A plus B by Q. So this third option will be correct. Here you can see that half of minor axis is named as semi minor axis, and half of major axis is named as semi major axis. Is it clear? So let's move to next page. Here we have to solve a numerical. The distance of two planets from the sun is 10 to the power 13 meter and 10 to the power respectively. Find the ratio of time period of planet. So we all know that t square proportional to r cube. So if we write here r1 cube in place of r1 cube, we will write 10 to the power 13, and in place of r2 cube, we will write 10 to the power 12. And if you divide these two equations, you will get t1 square by t2 square equal to r1 cube by r2 cube. R1 is given 10 to the power 13, R2 10 to the power 12. So by simplifying it, you get value T1 by T2 in ratio 10 root 10 is to 1. Next numerical is that the satellite of Earth is 5 hour. Okay, 5 hour is time period. If the separation between the Earth and the satellite is increases 4 times the previous value, calculate new time period. So here we will use same formula. Initially time period was t, so you can write t square proportional to r cube. After making this distance 4 times, time period become t1. So t1 square would be equal to proportional to r, because r changes to r1, right? So again, if you divide these two equations, you will get relation in r1, r and t1 and t. What is r? R was initial separation and r1 is final separation. So by simplifying it, you will get T1 equal to 40 hours. Value of T was 5 hours. But if you make separation 4 times, then time period of revolution become 10 times, 40 hours. So Newton's second and third law of gravitation. According to Newton's third law and universal law of gravitation, object attracts every object with gravitational force. What is this? This is Newton's law of gravitation. And what is Newton's third law? it's about action reaction. Every action has equal and opposite reaction. So Newton's second law is about force and change in momentum. What Newton's second law states? It states that force applied on any object is proportional to rate of change of momentum of that object. And what Newton's third law states? State every action has equal and opposite reaction. And what is universal law of gravitation? It is uh, force of attraction between any two objects having mass. What happens when a ball is dropped from certain height from the ground? So if you drop certain height, it start falling downward, and who is attracting it or pulling it downward? This is gravitational force. So ball is seen falling towards the earth, but the earth is not seen jumping towards the ball. Why it happened? If both are exerting equal force on each other, as Newton third law says that every action has equal and opposite reaction. So if I drop any object from certain height towards the ground, then this object will also pull Earth towards its center. So why Earth is not moving towards it? Why this object is moving towards Earth? But both are exerting equal force on each other. Students, this happens only because this object is very light in comparison to mass of the Earth. Both are exerting same force on each other, but that amount of force enough to move this object. But same force is not enough for motion of Earth because it has greater inertia, has much more mass than mass of this object. So did you understand why Earth is not moving? Because Earth has a greater mass in comparison to mass of this object. That's why instead of acting same force between them, this object is falling towards Earth, but Earth is not moving towards this object. Same situation arises in a situation in which apple is falling towards the earth from tree, but earth is not moving towards this apple because instead of same force between them, this mass is lighter in comparison to mass of the earth. So this force is sufficient to move this object, but this force is not sufficient to move earth towards the apple. Okay, so I hope you understood these concepts. Let's move here. Let M and M, capital M and small m, be the masses of earth and ball respectively, and A and small a be the acceleration of earth and ball respectively. So small a is acceleration of ball. So it is equal to F by m. So forces in both cases are same. But here this one, small a is divided by small m. So if you divide any number by some small number, then you will get a greater value. So a is far greater than capital A. You can say that this object will move with greater acceleration in comparison to acceleration produced in the earth with same amount of force. Let's talk about free fall. So what is free fall? If you drop any object near the Earth's surface, then it will move under the gravity. So only force acting on this object is force due to gravity. And this object will start falling towards the Earth with acceleration g. And this kind of motion is named as free fall. So when a body falls from some height towards the Earth, only under the influence of gravitational force and no other force should be acting. Only force acting is gravitational force and no other forces act on it. The body is said to have a free fall. The body having a free fall is called freely falling body. Is it clear? So Galileo proved that the acceleration of an object falling freely towards the earth does not depend on the mass of the object. So if you drop a coin and a feather from same height, then both will fall on the ground at same time. How it happens? So this happens here, vacuum is created, because if some air would be there, then air resistance will start acting and both will not fall at same time. So if vacuum is here, vacuum is created, then forces acting on both objects will be different. Suppose mg force is acting on this capital M and small mg force acting on this one, small m. But acceleration produced in both the object will be same. What is acceleration? Force upon mass. So to get acceleration, we have to divide by mass. So this mass will cancel out. And here we have to divide mass of coin. This will also cancel out. So in both cases, we are getting same value of g. So both will start falling downward with same acceleration, which is equal to g, 9.8 meter per second square. The feather and coin fall with same acceleration and reach the ground at the same time. Okay. So students, that's all in this lecture. In next lecture, we will start how this acceleration due to gravity varies with depth of the earth, inside the earth, and with height above the earth. We will learn about this concept in next lecture. Okay, so that's all for today. Radhe Radhe.